It says streaming, so I just want to double check to make sure we are streaming. Everybody can watch me, watch myself stream here. I love it. View my profile. What am I seeing? Yes, I am. So we are streaming. Okay, so we're live there, and I'm sure we are live on YouTube. I can only guess, imagine that we are. I'm just going to double check, make sure that everything is working fine, and we are good to go. All right, so we are live on 3 different channels. Seth OBrien, thank you for joining us, and David Smith.
Thanks for having us.
No, yeah, I tell you what, we're going to have a blast. I don't know about you, but um, the last two sessions have been doing unbelievably good on our LinkedIn and YouTube. I think the Alexa switch has gotten almost 1,000 views so far.
That's awesome.
Yeah, so we're doing really good. But today's discussion is on the safety disconnect. I threw in safety because in my mind, that's when I think about the disconnect switch, I think about electrical safe work practices. I think safety, so I call it a safety disconnect switch. But in reality, that's not necessarily the right terminology, right? It's just a
Yeah,
disconnect switch.
yeah. I mean, the industry term, especially if you've worked at Eaton a long time, it's a safety switch, right? But yeah, switching devices is more of the general term. But yeah, just a big on-off switch.
Yeah. So Seth, this is your first time streaming with us. I know everybody knows the guy to my left or right, in the middle. Everybody knows the guy in the middle is David Smith because he's like a fixture and he's helping make things happen. But Seth OBrien, who is Seth OBrien?
Yeah. So I am currently the Flex Center manager for our switching devices business located in Cleveland, Tennessee. So essentially, I manage our custom switching business. Kind of have responsibility for sales and marketing, as well as strategy and new product development as well. So kind of touch the business and all different angles. Been with Eaton for about 8 years now. Started in sales, did a sales role in New York City and a sales role in Los Angeles. For our New York was resi and light commercial. LA was OEM, and then I was after that I was a product manager actually for HVAC variable frequency drives in Milwaukee, Wisconsin. So a different part of our business. So kind of changing it up, going to
Cool.
our core side of our business, going to the switching device business, and it's been a good change.
Excellent, excellent. And so David Rodriguez has joined us. Gustavo has joined us, and Mr. Ryan Jackson has joined us. So we're getting some people on board. And so, Seth, I know you piqued my interest in your Factory Floor Friday videos. You were doing an
Hmm.
absolute awesome job in putting those together, and I love the concept of Factory Floor Friday.
Yeah, thanks. No, yeah, it's been fun. I've seen kind of from the other side of this. I've seen them for a long time. I've seen different posts and things like that, and the video was really, I mean, similar to you, right? Similar to you taking this on and trying to figure out how do we engage with uh, uh, customers around the world on a more regular basis in a time when can't travel. I saw this as kind of low hanging fruit. The Factory Floor Fridays, they generate a lot of intrigue and comments and likes, and I think people enjoy them. So decided I'd try to take it up a notch and go with the videos, and it's been good. It's been a fun one.
Excellent, excellent, perfect. Yeah, thanks for adjusting that. All right, so and I really love that, and the disconnects. So I call the Flex Center the custom shop, right? Special orders don't upset us, and you guys are out of right here in the United States in Cleveland, Tennessee, right?
Yep, that's correct. Yeah, and I would say that's the best way to define it to other people. Custom switches.
Absolutely, and you could probably bail a lot of people out of jams when they need you. But I've seen the gold switches. I've seen the switches that have the United States flag on them. So you guys can paint switches different colors. You can make them look really cool and stick out like a sore thumb. I think that is absolutely awesome.
Yeah, that's the one of the more fun mods we get to do, right? We get to paint them up and make them look cool. Like you said, the flag one is on display on most of our
Yeah.
slide decks, so that's a fun one. But yeah, we can do that for many reasons, and it extends beyond just looking cool too. There's some safety plays. There's some,
Oh.
blending in with the environment you're in, or using it as a promotional tool as well. So lots of reasons.
Yeah, that's pretty cool. So from a, I can get the say, you know, I can get the both the safety and the blending because I've seen like on the outside of some buildings they want the enclosures to match the structure. So what would you say, Seth, if David Smith decided, you know, he put this big gray box, this switch that you personally put together, Seth, and you shipped to David's house for a project, and he's out there on a job site, and he says, "I think I need to get this thing gray, out of the gray and into like a tan."
Hmm.
Can he just take a spray painter and just paint that device? Is that something that is kosher?
I guess he owns the product. I guess he could do it, but I don't think it's gonna last really well on there. A big part of it is really around the quality and what you're using to make sure that it lasts long term. Right?
Hmm?
We do an e-coat process in the facility, so we do a really heavy industrial type of paint. We also do powder coating, things like that. Um, if he wants to mark it up and write his name in letters on it with a spray paint can, I can't stop him. But I certainly think we could do a better job for him if we did it here.
But there wouldn't be an issue with um, the rating of the equipment from a 3R or a 4R or anything like that. There wouldn't be any issues with the ratings of the equipment. It wouldn't void the listings or anything like that.
No, I don't believe so. I don't think the paint on the outside would change the rating if he was to do that. I don't believe so. I could be wrong, but
Yeah,
I don't think
I
so.
I can't think of any reasons either. But you know
Yeah,
what
and
color
just
would you?
very quickly,
Yeah,
Tom, very quick. Yeah, well, number one, I mean, I think around this area, probably the three stars for the Steelers probably would be pretty popular around here. But I
hmm,
do know, like, I've done different tests and assignments to where different electrical equipment would not allow that. For example, if you went and painted a panel board or something like that,
yeah,
there could be a possibility to where that particular paint could void the warranty and make it so that the busway essentially on the inside of the panel board would not be as conductive as it might need to be, and it could be a safety hazard to the point where you might have to replace the entirety of the equipment. So that's a good question to ask, and that might be something we should. It's good for you to Seth for you to answer that because if let's just say it would be very much recommended, at least I would, to say if you're trying to make any type of aesthetic changes, I would at least contact Eaton or at least the manufacturer to ask
yeah.
if those are available because we would be able to make those changes at the factory level rather than in the field, which might be less safe as where it comes to making those particular types of changes.
Yeah, and
Yeah.
you mentioned something really important, and I think that like on the panel board side of the business, what do? We always mount the panel board, and you don't have the covers on yet. You don't typically have the breakers installed, and then the painters come in and start spraying like a madman, right? And we try to barrier off and protect the bus and all that good stuff. But not like on a safety disconnect switch. If you're going to start painting it, you've got to think about any ways those chemicals can possibly get inside that enclosure. Because to your point, David, the moment that your internal bus or the contacts, Seth, get covered with paint or other materials, now you're jeopardizing the rating of that equipment. So you've got to take a lot of care You may think you're only painting the outside, but in reality, it gets elsewhere.
Yeah, no, it's a really good point. And obviously, we paint our enclosures entirely before we do anything else to them, right? Before there's nothing. I mean, there's
Yep.
nothing inside of them. So definitely, if you need a custom color, I encourage you to contact me, and I'd be happy to do any color you want. We can do it, and we've actually done black and gold switches
Nice.
for Pittsburgh. It's been done. It wouldn't
Sure.
be the first time. We did a Kansas City Chiefs switch a couple
Oh,
years ago after they won the Super Bowl,
cool.
for the sales team out there. I mean, we really can do just about anything. I see a comment in there about would the type and commotion of paint affect it, or sorry, the second part. How
Composition.
about identifying it um, as electrical equipment for safety? So that's actually what I meant by how paint can be used for safety. So that's a really good point. A lot of people don't think of the significance of it, but if you're in a C, or imagine you're in an industrial manufacturing facility and you walk out and there's rows and rows and rows and rows of equipment that's being used on a daily basis in a sea of ANSI gray, right? In a sea of ANSI gray, a yellow or an orange safety switch would really stand out. And that then identifies these are the switches that you go and you turn off in case of insert situation here. So that's identifying an easy way to identify the switches you go after first in case of that specific type of safety need. So that was a great point there.
Cool beans. Okay,
I'm
so
just imagining like a detail shop for some reason in my head. This is
yeah,
very 2000s MTV, checking out the rides and doing the detailing of everything, in my opinion.
not a chop shop, just a detail
Oh,
shop.
okay. Pardon.
Yeah, we're definitely not a chop shop.
Oh, you gotta love it. Okay, so Seth, the code covers switches in Article 406, and I'm sorry, 404. Article 404, it handles switches, and I was reading through that just before this, and I was just glancing, get my head in the game, so to speak, and there are marking requirements and all that good stuff. So what I'd love to do is have a short I'd like to have a discussion around the ratings of switches, because what you're talking about, there are things in the code which we call snap switches, which are your light switches and things like that. Those are not what you are talking about. You're talking about heavy duty switches and general duty. Is that what they call it?
Yep,
So let's
that's correct.
start right there. What's the difference between a general duty switch and a heavy duty switch?
Yeah, so at a high level, a heavy duty switch is a much more robust product. It has a longer mechanical and a longer electrical lifespan rating, right? So it's tested for more mechanical operations, opening and closing the switch, as well as electrical life is tested to exceed those times. I don't know them off the top of my head, but I do
Mm-hmm.
know it is more robust. Um, Another one that is a simple one is simply heavier duty materials that are used to make a heavy duty switch, thicker gauge sheet metal and stuff like that. And then one key piece is that in a heavy duty switch, the door has to be mechanically interlocked with the handle. It does not have to be the case on the general duty switch. So the general duty switch, technically, you can open the door without turning off the switch. And a heavy duty switch, you cannot do that. You have to actually turn off the switch before you can open the door. So those are some of the high level major differences.
Okay, so in some cases in the code, we might have requirements that says you have to have that interlock, and if that's the case, you're definitely buying a heavy duty switch as opposed to a
Yep.
general duty switch. Okay, that's interesting. Now
And
go ahead.
I was just going to say, and the other one is really around modifications, like my business, right? So obviously, plug for my business. Typically, the majority of modifications that we can do will be done on a heavy duty switch. It's just it's a better starting point to work from. So typically speaking, what Lloyd just said was true, but we also allow for more custom solutions in a heavy duty switch rather than a general duty switch as well.
Excellent. Now, Ryan pointed out on the color side of the business, he said a different colored equipment could be a nice way to satisfy 70E's 130.7F. Now, 130.7 in 70E is titled Personal and Other Protective Equipment. A is general, B is care of equipment, C is PPE. C is PPE. There's a lot of subparts to C. Holy cow. 15. Jeez, you gotta go to get the D. Other protective equipment is D, and then E is alerting techniques. So he's talking F. Lookalike equipment, where it says where work performed on equipment that is de-energized and placed in electrically safe condition exists in a work area, other energized equipment that is similar in size, shape, and construction. So what they're talking about there is when you lock and tag out a piece of equipment, but you locked and tagged out the wrong switch to that piece of equipment. So what he's saying is the color may help satisfy and meet some of those requirements. And I would say anything also in E, alerting techniques as well, because they've got safety signs and tags. You've got barricades that have to be used. You have attendants. So there's other safety aspects, and 70E is another important document. So I'm looking at the 2021 version of 70E, and you can't go wrong with the 2020 code book. So you've got to have them both. They go together. The only thing I need is my 70B for maintenance, which we will talk about maintenance of switches as well. I've been doing my homework, Seth, and you've got some good documents in that regard. Okay.
Yeah, one thing I will say too, in regard to this exact same conversation, the most common color we paint switches outside of gray, of course, is red. And that's for the fire systems, right? So similar concept that you were just talking about. The idea is the fire department knows exactly which switch to go to, right? There's no hesitation. There's no question of which switch is the switch for the fire pump, right? And they can lock it on, and that's what they do. They actually go and they lock it on, so that way that pump will not stop, or will not be stopped by lack of electricity, at least.
Yeah. Now the whole color thing goes out the door when you're colorblind, right? And I know that's a challenge for some people, and I know there are ways to get around that. That you could, I mean, if you could put a Steelers logo, you could also put into the paint some other identifying marks for that equipment, custom for. And that's the nice thing about the custom shop is if a customer in their facility says, look, all of my disconnects from motors have to be this color and they have to have this M on it, you could make that happen.
Absolutely.
That's kind of cool.
It would not be a problem. And the other thing we can do is identify through other devices, right? So you want a pilot light on your device that's lit or not when you're in a certain condition, we can do that.
Yeah.
Stack lights, another example, right? Maybe you want it to stand out with a stack light on top of it for whatever reason. Again, something we could do, right? So really, we can identify them in any way that works for the customer.
Cool. And Robert, I think it was Robert. No, David Rodriguez asked, is there a difference between a safety switch and a disconnect switch? And I think I addressed that right in the beginning, David. I call disconnect switches safety switches. And that is just me. And I think a lot of people do that because the perception is that disconnect switch is there for safety reasons, to create and establish an electrically safe work condition. If there's a fuse inside of there or a circuit, you could have a fuse or a circuit breaker in there, right?
Yeah, they're two different products, but yeah, we have enclosed circuit breakers as well.
Yeah, so that disconnect is there to possibly to reduce incident energy, provide faster clearing time to protect equipment, to help achieve short circuit current rating, application issues, things like that. So And we could have a debate all day long, and this is really a fuse debate on whether or not you can use up, over, and down, but up, over, and down can be used for a lot of equipment like busway and things like that. And a safety disconnect switch, a fusible safety disconnect switch, can go a long way to help you meet the SCCR requirements in 110.10 of the NEC. All right, so we established we're not talking about, now let's just do this real quick. I'm going to see how good I can do this. Look at that. It was a push of a button, and it's all working. So what I did in this is I went into the code and I looked at the definitions of safety switch, because we're going to be talking about ratings. We've already established that what we're talking about here is not a snap switch. Now, when I looked at the NEC, they have various definitions in there that have the word switch in them. Switching device is a device designed to close, open, or both one or more electrical circuits. So you could have a switch. Can you have a switch feeding more than one load?
Yes, you can. And we make it easy. We're actually the only UL listed alternate lugs. So we have lugs that have multiple barrels, right? So that you can actually do this easily. And we're the only ones in the industry that actually have that. So if you need something like that, we're your call.
Awesome. So you have one source coming in and multiple going out.
Yep.
That's pretty cool. Now, lugs brings up another. I mean, I you know what I'm like? Every now and then I have my squirrel moment. And when you mentioned lugs, and I'm going to ask you a question. What this equipment, and I know that I'll get this question often, especially in the PV world for a PV disconnect. I have a 90 degree C conductor. I want to use it at 90 degree C ampacity. Is your equipment 75 or is it 90 degrees C?
Yeah, so you can use the lugs are rated for both, right? But when you're sizing the lugs, you have to use the 75 degree C column. You can't use the 90 degree C column. So just per UL requirement, you have to use, regardless of what the cable is or the lugs are or whatever, it has to be sized per that 75 degree C column.
Yeah, and you can land a 90 degree C conductor on a 75 degree C lug, okay, or a 90 degree C lug. But when you're using a switch, now, does it matter if it has a fuse in it or if it doesn't have a fuse in it? Doesn't matter. Okay.
Same thing.
All right. So regardless of whether or not you have a fuse, an overcurrent device inside, that switch will require you, it's 75 degrees C. You have to use the 75 degree C column from an ampacity perspective. Now, we got Ryan Jackson and David Rodriguez and all these guys. They know conductor sizing and ampacity adjustment factors and things like that. They can use the 90 degree C column if the conductor has 90 degree C insulation, all that jazz. But you can't exceed the 75 degree C column. So that's good to know. That's good to know. And that has to do with heat. The other lug question, what about fine stranded conductors?
That's a good question. I honestly don't know the answer off the top of my head. I'd have to look up our lug document.
No, you know what? I think, I would never ask a question I did not already.
Yeah, I was about to say the only reason Tom asks these questions is it's more of a quiz, and then he just is able to,
I feel like I'll take one that I don't know so far. I'm happy with that.
Look at this.
You've done very well.
Thanks.
Safety switch, fine stranded wire guidelines. We have an instruction leaflet on it, which is freaking awesome. So
2013. Look at this.
I know, and it's 2021 already. So this is so what's fine stranded and terminations. It's about the right time frame from a code perspective, but the National Electrical Code had made some adjustments in the NEC with regard to terminations. Fine stranded was a point of debate and discussion in the industry. And so a lot of people were trying to say, how do I handle fine stranded conductors? The good thing is I put a link to that in the description so that everybody has this, and it's, this doesn't change. The challenge with fine stranded and a lug is all of those strands. You've got to make sure you crimp it correctly, and it has to be listed for the use with fine stranded. So this is an interesting document that I put as a reference, so everybody has that when they have that question. If they have that example of fine stranded conductors, which could be, I think the welding cable is fine stranded. The way I always look at it, if that cable is thick and really flexible, it's fine stranded. Okay. And Robert from Omaha was talking about ferrules, and ferrules are, I think, a really good way. I like ferrules in most terminations, because especially any stranded conductor, if you think about that stranded conductor pushing it under the lug, here's what normally happens. I always have that stray dog. He comes out and then he loafs over this way, or I get two of them, and then you got to pull it back out, turn it up, put it back in, and then you get that. I like the ferrule aspect, but I think you've got to really look at the equipment to make sure it's listed for use with those ferrules, those little barrels. And yes, the doc is available. Robert from Omaha. I put the link. It's either on if you're on YouTube, so it'll be in the YouTube description. At least it should be. Cannot load to 90-degree column, Robert, so need to make sure labels. Okay, so we're caught up on there. All right, so switching device, very simple, and we can supply multiple loads. Whoop. There's your general. Now, general use switch, branch circuits, it's rated in amperes, and it's capable of interrupting its rated current at its rated voltage. So I saw a couple things in here. There's a general use switch, and then there was an isolating switch. This one, it has no interrupting. So an isolation switch has no interrupting capability. You have to de-energize and remove all the load before you open it. And then there's the general use. That's a snap switch. So that's not what we're talking about. Your general use snap stitch. So boom, that's what we do with that definition. But an isolation switch, so this has no interrupting rating, and it's intended to be operated only after the circuit has been opened by some other means. So I'm sitting there, and I don't know if you know the answer to this one, but I know in my head, and I'm not sure I know the answer to this one either. How do I identify an isolating switch? Like, it's a heavy duty switch. You can open that under load, can you?
Yeah, they're load make, load break. So you can absolutely do that on both general duty and heavy duty.
Okay.
And so that's an interesting one. Also, all of our switches have interrupting ratings. So by code, I think we have to have 10K IC. So our non-fused disconnects, right, at a minimum, they are 10K IC. So this one,
got to be careful.
am I saying it wrong?
Yeah.
What am I doing wrong?
Yeah. So here's the thing.
SCCR versus interrupting rating?
Yes.
Right.
So that's the short circuit current rating. That's the ability of that switch to hold its contacts closed and not blow open, right? So This is the load current. So I guess most switches are, unless you have, if there's a fuse in there, or if it's a breaker that has an instantaneous, right? So those will have interrupting ratings because the fuse and the breaker act to interrupt the fault current. But an interrupting rating does not necessarily mean fault current.
Okay.
If I look at the definition of interrupting rating, it says the highest current at rated voltage that a device is identified to interrupt under standard test conditions. So you might say a load current, the highest load current, like say it's a 600 amp switch. You might say, I need to open under 600 amp switch. That's an interrupting rating. It's not necessarily a short circuit, but it is stopping the highest current. So, but it sounds like that this switch is only designed and intended to be operated only after the circuit has been opened by some other means. So my suggestion to anybody who's using switches, but if you have a general duty or heavy duty switch, you don't have to even think about whether or not it is a isolating switch only. If it's not that type of a switch, then you really should read the manufacturer's instructions to make sure it's not an isolating switch, so that you don't misapply it. But an isolating switch, I have not come across an isolating switch. I don't know. I think Robert's out there from Omaha, and we've got David Rodriguez, we got Ryan Jackson. So if you guys have examples of an isolating switch, I'd love to see them.
I'm very curious what it is now.
Yeah, so I'm telling you, this is the nice thing about these events, man. So we are all, well, this is like all learning. Switch motor circuit. So a switch rated in horsepower that is capable of interrupting the maximum operating overload current of a motor of the same horsepower rating as the switch at the rated voltage. So some switches have horsepower ratings.
Yep.
Right? So
They do.
Do all switches? Is that like a standard UL98? Well, what standard is a switch listed to?
Oh, there you go. You answered it. Yeah, UL98.
Yeah.
UL98. So that was something I had to get used to actually coming here from the OEM world. I'm so used to 508,
Yeah.
which, makes it so easy to change things around and try to utilize different UL listed components to help solve problems creatively, whatever. And it's just so much more rigid and very different. So it's been an interesting transition to UL98. But yeah, all of our switches are listed to UL98.
Excellent. And Ryan pointed out a good point. In fact, on the isolation switch, and I did do some homework. If you go to 225, this is medium voltage stuff, which is why, Seth, you're not all over that, right? Because you're not into the medium voltage stuff.
I didn't want to say it, but yeah, that's out of my realm for today.
Yeah, that's fine. So 225.51 is in, remember, Article 225. I should ask you, David. I should ask you if you know what Article 225 is. Article 225, if you look at 225.51, outside branch circuit, so Part 3 in Article 225 is over 1,000 volts. And they say an isolation switch, where it says where oil switches or air, oil, vacuum, or sulfur hexafluoride circuit breakers constitute a building disconnecting means, an isolating switch with visible break contacts and meeting the requirements of 230, 204B, C, and D shall be installed on the supply side of the disconnecting means and all associated equipment. So you're going to see an isolation switch in the medium voltage applications. 225, somebody just put, Robert Omaha just put 225.51, and then 230. What section? What article's 230, David?
Services.
Excellent. 230.204. 230.204 is isolating switches. We got a whole section with it. It's the title, isolating switches. Where oil switches or oil, vacuum, or sulfur SF6 circuit breakers constitute the service disconnect means, an isolating switch with visible break contacts shall be installed on the supply side of the disconnecting means and all associated service equipment. So that's where you're going to see this isolating switch. Well, the mystery has been solved, as Mr. Clouseau would say. All right, so all these references in section over 1,000, over 100 volts, all these referenced in sections over 1,000, it means 1,000 volts. Yes.
He needs 1,000, yeah.
Yeah, 1,000.
Yep.
Disconnecting or isolating switch, disconnector, isolator, a mechanical switching device used for isolating a circuit or equipment from a source of power. So we already talked about that. A switch capable of making, carrying, and interrupting specified currents. And that's your heavy duty switch, right? your heavy duty switch can interrupt specified currents, which could be the load current.
Yep,
So,
absolutely.
Seth, are you aware of the I think it's 12 times or the capabilities of what it can interrupt?
Yeah, 12 times make, 12 times break, I think is
I
what it
think
is.
that's what
Or
it is. Yeah. Yeah. So a switch can actually from a testing perspective, we test that switch to stop the flow of current up to say 12 times. It's the 12 times make and break. So if you think about that, those physical contacts, when they're separating, you're drawing an arc.
Yep,
Do you have arc shoots in a switch?
absolutely. In
That's
in our and I guess I don't know the answer to this one. I know we have them for sure in our heavy duty switches. I do not know for sure. I'll have to look at a switch in a second on the general duty switches, but I
okay.
do know I can picture it in my head on the heavy duty stuff.
Okay. Okay. But not all switches are rated for closing as we just talked. So and that was just a little squirrel moment of looking at the where's the three of us looking at the some of my slides on the code stuff, because I wanted to at least talk a little bit about some of the definitions that are in the National Electrical Code. I do have our catalog as well. So if we have to go back to the catalog for any reason, I've got a copy of the catalog, which I provided to everybody in the links as well. So let's talk about voltage ratings.
Mm-hmm.
Your group doesn't do the residential stuff, which is the 120 volt snap switches. You don't do the medium voltage stuff, which is the big boy switches, and I'm sure I'm going to have a medium voltage program. So this is really 1,000 volts and less.
Yeah, exactly. We do, our standard switches come in either 240 or 600 volt
Okay.
options, right? So that's typically what we rate them to. We do have some DC switches as well, so we do have 1,000 volt options there. But yeah, typically speaking, when you're thinking about our products, it's under 1,000.
Okay, so the 1,000 volt stuff was pushed really due to the PV industry.
Hmm.
Do we make 1,000 volts disconnect switch?
Yes,
Oh, we
do.
do. Ah, okay. I didn't know. I didn't think. And that's that. See, David, I learn
Hey,
something every day. So we make a 1,000 volt disconnect switch. That's probably for the PV. Is that DC or okay? So
That's the difference. It's DC.
it's DC. Okay, so let me ask you a question. Difference between the construction difference between a DC and an AC switch.
So I am not well versed in all of them, but I do know that we actually utilize polarity of magnets to
Yeah.
help break break the loads at that high of a voltage. So I don't know. That's about as much as I can tell you on it. But I
Yep.
do know that we utilize magnets to actually help achieve those ratings.
Yeah. The challenge that a circuit breaker and even fuses have is that your DC current doesn't have a zero crossing. So what we love, switches and breakers and fuses, love a zero crossing. When you don't have a zero crossing, then you've got to somehow figure out how you're going to stop the flow of current. You're typically not going to do that with one set of contacts. So I know on a lot of DC switches, there'll be 3 poles in there, but you've got to wire them in series because, like Napoleon, we divide and conquer. Okay. So now you brought up the magnets, Seth, and that's a good point that in some cases we'll put magnets in there, but if you've got to be careful because some manufacturers will put magnets and then you can't reverse power feed through that switch because of the placement of the magnets. And I think we've addressed that where we can have reverse power feed. but some others can't do that. So that's another thing to be careful of. And David, are you aware of how, if I have a breaker or a fuse switch that's labeled line and load, can I reverse power feed through it? Putting you on the spot.
I do not know. I can honestly tell you that.
Yeah, if it's labeled line and load, then you cannot put back feed through that, and that's actually, it's wrong in 705 because they got the language wrong. In 705, they said if it's a switch that's labeled line and load, you can, and you can't.
I would imagine that's why you have the label.
Exactly right. If I say this is my line and this is my load, you can't mix
If
and
it was
match.
reversible, then there wouldn't need to be a label there, right?
That's exactly right.
That's why whenever I have my reversible shorts, it doesn't tell me which side I have to wear them.
That's
Just
right.
go either
You
way.
get twice the
That's
life
a
out of
very
it.
good analogy. I like that.
I'm going to use that. I got to get a pair of shorts with the label and say, which way would you wear? Is the label in or the label out?
That's right. That's my show for today, ladies and gentlemen. That's all I do.
I love it. Atef Al Jarrah, he says, is that valid for all types based on AC categories? I'm not sure what he was referencing on that, and I think he was talking about the voltage. And you clarified, Seth, that we do up to 1,000 volts on DC, only up to 600 volts. Ryan Jackson says, consider that joke stolen as of right now. I love it.
We're doing a public service here.
That's right. We're just providing resources to the industry, Seth, and
Sure.
You never know what kind of resource you're going to get.
Hey, you know what? To be
I
honest,
just want to know how many counters we're going to go to now out in the real world. How many counters we're going to go to where they have a pair of reversible shorts
True.
to help people understand this. So that will be the real test to see how many people are paying attention. How many pairs of reversible shorts do we see out there?
Right.
Yeah, how much penetration we have in the market. Honestly, to be absolutely honest, hey, if that's the kind of stuff that makes you remember this particular types of stuff in the industry, the technical stuff, then hey, I mean, that works, right?
More power to you, brother. Absolutely right.
Right.
Okay, so we talked about the voltage. We got up to 600 volts. What was the lower voltage? To 240?
We do 240.
All right. So 240 volts, all the way up to 600 volts. We got up to 1,000 volts in DC. Now, how about current ratings? I know there's there's break points for switches, right?
Yeah. So we've got 30, 60, 100, 200, 400, 800. Or did I skip one? Did I skip 600?
Do we have a 600?
400, 600, 800, 1200. So that's it. So it's just 30 to 1200 in those break points.
Okay. Now, in a fusible switch, if I bought a 60, I can put any fuse in there above 30 or up to 60 amps, really, right?
Yeah, up to the rating of the switch for sure.
Okay.
Yeah, so you can fuse it down, right, to be a 40 amp circuit.
Right. And you might not know the answer to this one, but I know that a fuse clips, when you have a non-current limiting fuse versus a current limiting fuse, there's rejection features on the current limiting. Standard, do we put current limiting fuse clips in there or not, or like a class H type of fuse clip?
We standardize mostly on class H.
How do we change that? Seth, I'm appealing to you, brother. How do we make them all current limiting?
So good news is I love to make this modification in the factory.
I love it.
So if you want current limiting fuses, if you want a different class of fuse, that's one of the many mods that we offer. So we're happy to change that up and put class R fuses in there.
Okay.
And just make that a little bit easier for you to put whatever type you need in the switch. There are some limitations. Obviously, the sizes of those fuses change fairly drastically sometimes, depending on which class you're looking at. So, we come talk to us before you assume we can do it, and let us just make sure that we don't need to change the enclosure size or something like that to accommodate a change in fuse. But we can do whatever class fuse you'd like usually.
Perfect. What are you, do you want current limiting fuses, David?
It depends on the application, I guess, right?
Oh man.
Yeah.
You guys,
So I tell Tom, I have a absolute 100% like absolutely out of nowhere question for you. Okay.
okay.
This is all right. So because I might be opening up a little bit too much Pandora's box here, right? So because we have these particular switches that go up to 1,000 volts, and it might be just because I might be going off the path here because that particular switch is DC, but it sounds like Eaton offers above 1,000 amp switches for high voltage and everything like that. Because they're switches, and because they might have circuit breakers or fuses inside of them, they might be fuse holders. Then are we aware of any type of particular product that Eaton provides when it comes to switches for arc energy reduction? Because if that number starts to lower to 1,000 volts, then it might actually be coming across Seth's product line here, depending on the application. And so, like I said, my question is absolutely out of nowhere, and you have no time to actually do any homework. But, can you speak onto that and kind of, provide a little bit of light for some of the uneducated people, or at least less educated people, whenever it comes to that stuff?
So you're looking at like an arc reduction maintenance switch or something like that?
Right. Yeah. Now, is that kind of thing? There's the switches that we were particularly talking about. If they start to move down to 1,000 volts and lower, this particular product line, this medium voltage, is that going to fall under that particular requirement?
Okay, so two things. So Seth, I think you're up on the arc reduction relay that you can put in there. So I'm going to let you talk about that. But before we get to
Sure.
that, if you look at 24067, if you just
Right.
looked at 24067, the key thing to remember in Article 240 is 240.1, and I know this because I fell into this trap once. And when you fall, it's what it is like. It's like you get busted for something where you didn't know something, or you made an error, and then you get called on the carpet. It's like being up in the front of the class and the teacher calls your butt on the carpet, and then you fess up and then you learn something. So 240.1 is really important.
Okay.
What 240.1 tells us is parts 1 through 7 provide the general requirements for overcurrent protection and overcurrent protected devices not more than 1,000 volts. 240.67 is within those parts. So
Right.
the arc reduction requirements are not required for applications above 1,000 volts, but it doesn't mean you can't do that, right?
Right.
Now, the cool thing that Seth has is the ability to put an arc reduction maintenance switch relay in these shunt trippable switches. Seth, why don't you talk a little bit about that?
Yeah, so it's again, I've said it a lot. I feel like a broken record, but it's an industry first. So we developed a arc reduction relay for our and you'll have to help me on this one. I want to say we designed this around 1,200 amps. Is that a code
Yeah,
driven?
yeah.
Oh,
240.67 is any fuse 1,200 amps and above. So if you look at that application, so it's any fuse 1,200 amps and above, you have to have one of those arc reduction technologies, and the arc reduction maintenance switch is the most cost-effective, fastest way to do that. But go ahead.
yeah, that's why I asked, because I just want to make sure I was speaking correctly on it. So it's a 1,200 amp switch. We offer the arc reduction relay that actually has very similar to like an ARMS ECB or ARMS circuit breaker technology.
So is it built into the product itself, or is it like an addition add-on?
It is something we offer with the product. I don't
I see.
believe it's forced. I don't know. Is that required on all 1,200 amp switches, period, or is it just service entrance? I don't know the answer.
All 1,200 amp
Okay.
fusible equipment. Yep.
Yeah, so I guess we'll be doing it on all of them.
Yeah.
Is what it sounds like. So
Absolutely.
the arc reduction relay has a maintenance mode switch on it. You just flip over a switch and it reduces that available or that incident current, and provides a little extra layer of protection for somebody who's doing maintenance in the area. So I think it's called maintenance mode, similar to what we call our
Yes.
Yeah.
circuit
Yes.
breaker That's the same thing on this relay. So it's similar terminology.
So you've got it for 1200 amps and above, but and I don't. You may have said this. I'm looking up UL 98 because a question came in, but can you put that arc reduction maintenance switch on anything less than 1200 amps?
You're putting me on the spot. I don't know. I knew you were going to ask this question.
You're the
way you're
custom shop, buddy.
phrasing it.
You could do anything.
Yeah, my answer is always yes on this stuff. So I'm sure we can. I don't 100% know the answer, and I will say I'll have to look into that and provide you a follow up. But
How
yes,
on
I'm
the
pretty sure we can.
on the shunt trip? What size? Because that's what you require is that shunt trip switch. Do you know what size down like what's the smallest shunt trip switch that we make? Let me look it up here. Shunt trip safety switch. It looks like we go down to 30 to 800 amps. So
Yeah, I figured it was all of it.
yeah, so as long as you have the shunt trip switch, you can put that relay in there. And here, let's do
So I
this.
can tell by looking at the relay, it looks like the pickup amperage that we have, the lowest setting is 100 amps. So I'm assuming we would default to a 100 amp switch and above.
Cool. Perfect.
That is kind of good to know. Just kind of think
Yeah.
about it because, Tom, just kind of give a little bit of commentary, right? It certainly seems like the arc energy reduction requirements. I know that you're saying the 240's scope only goes to 1,000 volts. However, just to kind of future-proof whatever installation might be going on, like it might be an 800 amp, or it might be 1,000 amp, or it might be even lower than that. But it might be a good idea just because the code doesn't require it. It still might be a good idea to throw that on there because it's a safety feature, right? And you might actually be future-proofing, depending on you don't know what's going to happen in 2 year code cycles down the line. It might actually drop down to 800, even lower. So, it's never a bad idea to have a little bit more whenever it comes to safety equipment.
Yeah, and I'm glad they took these efforts in designing it that way, right, to give us that ability to utilize it on different amperages. Now I know the answer every time someone asks. But the other thing that's really cool about the relay is it actually has overcurrent built into it as well.
Yeah.
Overcurrent protection. And what's really cool about that is what we're starting to talk about is fuse preservation. So we're actually able to trip right before opening a fuse, right?
Yeah.
So that's the idea is we should be able to capture that and preserve fuses longer, prevent them from tripping, if you will, in those situations. So.
Yeah, and that's and so another pet peeve of mine is that first panel board on the secondary of a transformer. That is very high incident energy because you have, if you think about that panel board, you have an overcurrent device that's feeding the transformer. Then you have a conductor on the secondary hitting a panel board. And the incident energy in that panel board is based upon the clearing time of the primary overcurrent protective device on the transformer. Okay. Now, just think about how I pick that primary circuit breaker or fuse. If my full load amps on my transformer is, 400 amps, I wouldn't put a 400 amp fuse or a 400 amp breaker on it. Why? Because of inrush current. So what do? And the code lets me go up to 250%, right? So I put a larger overcurrent device on the primary of that transformer so that it energizes and I don't open my overcurrent device. So I am adding an intentional delay. So my instantaneous is further to the right. My long time pickups are further to the right because I'm having a larger conductor as well. If I had 400 amps of full load amps on the primary, I wouldn't put 400 amps of conductor and then put a breaker or a fuse that was 1.75 times or 2 times that, right? So I have to size my conductors appropriately. Well, that adds an intentional delay. So what I keep telling people is that first panel board or switchboard, whatever it is on the secondary of that transformer, you're better off landing those terminations on a switch, a fusible switch, and or a breaker in a box, whatever you want to use. If you're a breaker guy, it doesn't matter to me. We make them both, which is kind of cool. Seth doesn't get upset if he has to make one over the other because he can make them both.
Right here.
Yeah, it's right here. So you take and you land your conductors first in that box, and then you feed a panel board, switchboard, or whatever it is downstream, or it could be a piece of equipment. Because what you're doing is that panel board, which is downstream of that disconnect switch, which is more likely to be, you're going to be going into that for justified energized work, either doing troubleshooting or whatever it is. Now you can reduce the incident energy by putting a fusible switch or a breaker, and then if you complement that with an arc reduction technology, now the electrical worker is set up for success, right? You've reduced the severity. You haven't changed the likelihood, because if he's going to get in there or she's going to get in there and do work, whether or not they drop a wrench, it's all on them, right? But if they did, you can reduce the incident energy at that equipment. And then from a likelihood perspective, you can facilitate now establishing an electrically safe work condition with that disconnect switch. So to me it just smells of safety for the electrical worker, and that arc reduction technology, which now you can put on a fusible switch even lower than 1200 amps, is advisable for those reasons. So it's all about electrical worker safety. So I was, and the reason I was over here, I called up the UL standard because Atef was saying, my question was about interrupting value for DC disconnect switch. Is it, as you said, 12 times for all types of switches, AC and AC 1, 2 and AC 3 categories? I thought he was saying DC as well. AC 1, 2 and AC 3. I guess single phase and 3-phase. I don't know if that's what he was talking about there or not. So I'm not sure but in any case, I'm looking at the standard, and it says switches for use with class 1 ground fault sensing and relaying includes those that are capable of interrupting 12 times their rated current. It doesn't say anything about whether or not it's an AC or DC switch or anything like that. They have the 12 times rated electrically tripped, and this is electrically tripped. So this would be like a shunt trip, right? And that's why you would worry about it. You wouldn't necessarily be, if you're flipping it by hand, being worried about it. You're worried about a relay telling this switch to open. And it says electrically tripped without integral lockout for use with class 1 ground fault sensing and relaying equipment. So the ground fault devices, the ground fault relays, is what drove that in the standard for the 12 times capability. And that's really the only reference. So and it's talking about electrically tripped, which right now we do that for ground fault, and we do that for the arc flash reduction maintenance switch, right? And that type of a relay. But I would guess that if somebody was out there getting creative and wanting to shunt trip a switch, they're going to have to understand that. Those are IEC terms for utilization categories based on the types of loads. Thanks, Ryan. So I'm not familiar with those AC 1, 2, and 3 terms, so I'm not an IEC guru. I have a hard enough time with the English language and UL standards. So we should have an IEC discussion one day. I'll have to put that in if I can get Kevin Lippert to come in, he's the IEC guru. Or even, I think... I
don't know if we can afford Kevin Lippert, to be honest.
Yeah, I know. All right. Okay, so perfect. How about the short circuit current ratings? I guess once you fuse them, you can get up to 200,000 amp short circuit current rating on anything, right? Pretty easily.
Yep, exactly. Yep.
Now, what about So what's the maximum short circuit current rating on a non-fused switch?
So they are rated at 10 KIC, but we also have series ratings that are published. So you can actually, if you use one of our specified upstream protective devices, you can get higher ratings on them, and we have a document for that as well.
Perfect. Perfect. You know, I had a gentleman call me one time. I did a presentation, and it was with Mike Holt, and Mike sends me an email, and he says, "Hey Tom, this customer says," because I told him, I said, if you have a non-fused disconnect, it's only 10K. Period. Now, if you have a fuse involved, if you have a circuit breaker involved, different story. But if it's non-fused, because we were talking about the disconnect that's used on the primary or the line side of a meter as a meter disconnect. And I said, you got to be careful, because non-fusible disconnect is only rated 10K. If your utility is giving you more than 10K to that meter socket, you're going to have an issue with the application of that disconnect switch, because you're exceeding its short circuit current rating. And that's just it sitting there, letting the current flow through it, right?
Yep.
And so Mike sends me an email, and he forwards an email to me about a customer who said, Tom is wrong. I have a safety disconnect switch. I have a disconnect switch from Eaton. I have an Eaton disconnect switch I used on my project, and it's 200,000 amps, non-fused. And he's using it. And so I'm thinking, okay, is Seth creating some stuff down in the lab that I don't know about, which is very possible. So he sends it to me, and he sends me the picture of the switch. He sends me the picture, the cut sheets from our catalog. And sure enough, and the first sentence in there, it says, this switch is rated 200,000 amps, and it was a non-fused switch. And the second sentence said, when protected by a class whatever fuse. So I emailed it back, and I said, well, you can't stop at the first sentence. You've got to read the second sentence. And we clarify that you have to have a fuse ahead of it. Now, if it's a service entrance equipment, you can take a credit for the fuse downstream based on how we test things. But that short circuit current rating is, I think, from a switch perspective, a non-fused switch. I don't think a lot of people understand that it's only 10K.
Right.
And
yeah, we get that question often. To be
yeah,
honest, yeah, we get that question often, and I reference that document I'm talking about quite a bit to help people, pick the right device to put in series with it.
that's cool. And I did a whole program on series ratings and all that jazz. So everybody can just pop out to the YouTube channel, figure that one out. Enclosures. So I was looking at the code today, and 404.4. So now we're in 404. 404 is for switches, and I know Ryan is going to 404.4 right now, as is Robert and probably ATEF. So if I looked at 404.4, it says a surface-mounted switch or circuit breaker shall be enclosed in a weatherproof enclosure or cabinet that complies with 312.12. So, Seth, and I think, David, you know about this too, panel boards. If I look at the definition of a panel board, a lot of people they don't understand that when I say a panel board, what you're picturing in your mind is a enclosure on the wall with guts and breakers. But a panel board does not include the enclosure. Okay? When I read 404.4 talking about damp and wet locations and about installing a switch in a damp or wet locations, it says that a switch, surface-mounted switch or circuit breaker shall be enclosed in a weatherproof enclosure or cabinet. it sort of implies that a switch doesn't include the enclosure. And I don't know if that's true or not. I everywhere else where we use the term switch, no, we never talk about an enclosure except for right here. But if I bought your heavy duty safety switch, I wouldn't have to take, which would include the enclosure. I wouldn't take that and put it in another enclosure.
No.
I would just buy a 3R or 4R or whatever rated switch, which the enclosure has that rating.
Right.
But it really, and that's why, and when I read that, I went back to the definitions, because I'm like, okay, when you look at panel boards, you got to go back to the definition and you'll understand that a panel board doesn't include the enclosure. But I don't have that clarity in this whole discussion around switches on whether or not, when I say a switch, if I'm including the enclosure in that switch. And it's important when it comes to the code.
Yeah,
So,
that's interesting. It almost makes me think that it's like an old school terminology, right? When it was a knife switch without an enclosure, right?
right.
Just that is still a switch. I'm sure it was considered I don't know if I'd call it a safety switch, but it's a switch.
I would be curious to see where, and I apologize, but
Yeah.
which UL, I think you might have been 89 that you might have referred to earlier, that falls under this particular, application. I wonder if they do testing, do they test the enclosure as well? Because if they test the enclosure, would that imply that the enclosure is part of the switch itself?
Yeah, I know. And Ryan Jackson points out that a general use snap switch needs to be in an enclosure. And I agree with that. But it doesn't say. It says a surface mounted switch. And so, and I'm just trying to, I just called up my little code, my Word document, and it's not surface mounted switch. It doesn't like me. I love it when. Okay, so surface mounted switch. In 404.a, I'm just looking to see where it's all used. And then there's a flush mounted switch. So that's the only place in the National Electrical Code where we use the term surface mounted switch. And I don't know that I fully understand what a surface mounted switch is. I agree with Ryan Jackson. General use snap switches need to be in an enclosure. And when it comes to your switches, Seth, I buy a disconnect switch that is rated for what types of enclosures, what kind of ratings do we have on our enclosures?
So we do NEMA 1, 3R, 12, and 4 and 4X as well.
Okay. So and we also have explosion proof switches, right? So
yeah, that's true. So yeah, we do actually have 7 and 9 as well.
Yeah. So Robert from Omaha says should be stated as an enclosed surface mounted switch, like enclosed panel board. Well, that's what I'm thinking, Robert. And I don't know that the code, I think, in my opinion, the code refers to a switch which would include the enclosure. Like when I say a disconnect switch, but a snap switch doesn't have an enclosure, right?
So are you telling me, Tom, that if you were doing some type of maintenance, let's say I don't know, maybe let's say you're reconditioning some type of piece of equipment, something like that, would the enclosure, essentially the simple part of asking your questionnaire is that, does the switch include the enclosure? Can you have a switch without an enclosure? If there's a switch that is not enclosed, is it still a switch? Or does it have to be enclosed to be considered a switch? Is that the question that I'm basically hearing?
No, what I'm saying
does it have an enclosure by definition?
I'm saying are the guts of the disconnect switch. So right. Like in a panel board, I can take the guts of that panel board and put it into another enclosure. It doesn't have to be an Eaton enclosure. I could buy another enclosure. I can have an existing enclosure. Take the guts for a retrofit interior, put it into
Yeah.
an existing enclosure, and now the question would be, and that's because that internal bus structure is the panel board.
Right.
Now, the question would be, can I do that? I don't believe I can do that on a safety switch because you have the handle that's a mechanism and there's so
Right.
many interlocks going on. I don't believe you can separate what's inside that switch from the whole enclosure, because Seth lists the entire enclosure together with the guts.
Right.
Oh,
Yeah,
really?
and to your point, the interlock piece is important, right? As soon as we do a mod that eliminates our ability to provide an interlock, we no longer provide UL ratings. So clearly that enclosure is part of this. I mean, it's a critical part of the switch, right? They're all, I'm like 99% sure that we only test with enclosures. We don't do any testing without, when we're
Right.
working on getting ratings and approvals and all those things. So it seems like it's more of just the integral part of the switch.
Yep. And so I think 404 404.4a needs to add some clarity, and 404.4 in general and 5, those few articles in the code need to be a little clearer, because this is truly all in one. I mean, you've got the operating mechanism, that mechanical interlocking. You're not going to take this enclosure and go to an existing enclosure and just retrofit that in. You're going to replace the entire box, and this enclosure is going to be rated. I see there's a gasket on this one here. What is this, a 3R? Looks like it might be a 3R.
Yeah, it's probably a 12-3R. So you would be able to put a drainage hole in the bottom, and it would be 3R. But they both use gasketing.
Yeah, so Robert pointed out that, Article 312 is your enclosures. And he's, like he said, Article 408 panel boards, 312 enclosures. Article 404 switchers, 312 enclosures. So 312 covers the enclosures. And I don't disagree with you, Robert. 312 covers the enclosures, and we have to follow, and Seth has to follow these requirements for enclosures. But you're going to buy a listed product from us or from whomever that has that rating.
Yeah, I don't want to install the interior of a switch without an enclosure in any application ever.
Right.
So
Yeah.
definitely agree with you that if that's the language, I think there's an opportunity there.
Yeah.
Yeah. So I think, Tom, is this the point where we say, I look forward to your public input?
Oh boy, public comment at this point. So I'd have to see if
Yeah.
we made any changes, but yeah, this might be a
I was
2026.
going to say, yeah, this would be new material, so I don't know if you'd be able to make it.
Yeah. So I'm just gonna, it's, and that's the thing, Seth, when you start reading the code, you really start to question, when you start to really look at it. That's why a lot of inspectors and people who use this on a daily basis, really, they'll find stuff like this and go, this is wrong. And then you scratch your head, why did it even get in there? But to your point, back in the day, we had knife switches that didn't have boxes around them. So, and then to Ryan Jackson's point, this might be really referencing a general use snap switch. I don't know, but a surface mounted switch, I can't find that term used anywhere else in the code other than right in this section. So anyway, so I like this document, Seth, which is safety switch renewal parts. So what this helps me. So David, you brought up, and you always do, like a broken freaking record. Okay. You bring up the whole concept of reconditioning. And remember, reconditioning, if I look at the definition, it is returning a product from a non-working condition to a working condition. And the second part of that says, this process differs from normal servicing of equipment that remains within a facility or replacement of listed equipment on a one-to-one basis. So, Seth, in my mind, if I have a renewal parts list which says you can buy these parts from me like this mechanism, the handle. Your intent is that I can make these changes in the field,
Yes, absolutely.
and we have instructions for all of that, right?
Yeah, for sure.
Okay, so this document, and I'm glad I stumbled on this one because I did not know that this existed, but I like, in light of David's comment, because I get a lot of questions from people to say, I broke my handle on my disconnect switch and I have to replace it. Is that considered reconditioning? And my answer to that would be no. This is normal servicing. We have a document where we sell you the parts. That would not be reconditioning. Now, if I have a Miller welder, I have a Miller 211 in my garage, and I like to weld, and I'll find any chance I'll weld anything I can weld just to practice. If I took that broken handle, say it was bent or whatever, and I cut it off and I re-welded it, now I'm reconditioning it because that's not a new part. I am trying to return it and I am doing it myself. You're not following manufacturer's instructions. But we have all of these parts in this document that you can buy. I mean, it's pretty extensive. I mean, look at this. You can buy the switching base all the ways up to a 1200 amp switch. So there are, based upon what I'm seeing here, there's a lot of things that we can do with switches when something goes wrong.
Yeah, I mean, there's definitely a lot of those pieces and parts can be provided. There are things that we can't provide, and I don't have the whole list, but I mean, there are certainly things that we can't do. But yeah, generally speaking, that we do try to make these things serviceable. So
Yeah. And so Robert says you are repairing. Okay, Robert, and I like that term.
Uh-oh. Here we go.
Here we go. I'm loving it. I'm loving this discussion because I get into this all the time. So it says electromechanical systems, equipment, apparatus, which is a lot of things, or components that are restored to operating conditions. So if I'm welding that handle, you can say I am restoring it to operating conditions. So I would meet that first sentence. Now, the second sentence says this process differs from normal servicing of equipment. Would you consider that normal? If I'm welding that handle together, is that normal servicing of equipment? I would say no. It's not normal servicing. And it says, or replacement of listed equipment on a one-to-one basis. There is nothing in this definition regarding repairing. So you are returning it to an operating condition. You're doing it on your own. You're not following manufacturer's instructions. You're not replacing a part one for one. So, and I would not call it normal. So when you get into that level of work, it's an important part. Now, Ryan Jackson says UL category WIAX is enclosed switches. And includes any switch whose operating mechanism is external and can be used without opening the enclosure. Interesting. And so Seth, the category code, the WIAX, that's sort of UL's way of giving a lot of information out to the general public who's not going to buy the standard. But they use enclosed switches, just like they use the standard for panel boards uses enclosed panel boards. And I know the NEC 2023 is looking at that language right now, and we're going to be changing the code to appropriately say enclosed panel boards when it's appropriate to say that. And Ryan, that is exactly what I was thinking. Maybe we should be saying enclosed switches. But I think the verdict and I agree with him that it's probably for knife switches and snap switches. It's not clear in 404.4a, but I think there's some clarity that could be added there. But I would have to really search everywhere we use the term switch to say, are we using it correctly? Should it say enclosed switch? Or is that correct? And it's minutia. I mean, it's details, but in some cases those little details make a difference.
I feel like Ryan Jackson just volunteered me for a job
Wait, where you see that at?
to go through the code and find where any enclosed switches
Yes,
where switches needs to be clarified.
and you can report back to Ryan on at our next Tick Tuesday.
Yeah, our next
I'll give you
enclosed switches admiration society meeting.
I'll give you 7 days. Okay, so we talked about enclosure ratings. You can purchase all these different enclosures, right? And they can put outside, and you have to follow the rules for all that good stuff. We talked about the lug temperatures, 75 degrees C. Doesn't matter if there's a fuse in it or not. 75 degrees C. So we covered that. We also talked about 24067. And we talked about you can go lower in the arc reduction maintenance switch. It's a shunt trip for a switch, so you got to have that shunt trip, and we can put those together. And and we talked about one example is that secondary or even the primary. And if you had a fusible switch that had that technology on it feeding a transformer, you can turn the arc reduction maintenance switch on the primary and provide protection through the transformer to the downstream. So that's a really good safety tool. I talked about that. Establishing electrically safe work condition. We already talked. So let me ask you this. Some switches I've seen have a hole that you can lock them on or off, and some switches have a hole that can only be locked in the open position.
Yes, that is correct.
Why is that?
So, yeah, I mean, it just depends on the application, right? So, lockout tag out is standard, right? So locking in the open position is on every product. So open up the disconnect switch and prevent power from going, downstream. Lockout tag out. That's what it's for. Now you can safely operate and work on equipment downstream of that. Locking on is similar to what I talked about before with like a fire application, right? If there is a switch that you want to be able to say, I don't want this to turn off no matter what. I don't want someone to accidentally turn the handle off or anything like that. We can add lock on provisions, right? I mentioned in a fire switch, the switch that feeds the pump for the fire pump has a lock on provision, and so that way the fire department can physically walk up, make sure it's on, then lock it on. So that way, if there's a fire that's being fought, somebody doesn't walk into the building or some maintenance person or whatever who doesn't know what's going on and oh, this is usually in this other position. I don't know why somebody would do that, but hey, kids exist. I have 2 of them.
Yeah.
So in that scenario, that's a scenario where you prevent that through actual locking provisions. So that's just 2 different examples of it.
That's cool. So now when is that a part of our standard, like in a catalog, would I have to order let's say that I did not want to have any possibility that you could lock it in the on position, only in the off position. Would that be a special order or is that a standard order?
Nope, that's standard.
Okay.
It's standard. Everything comes with lock off. Lock on is special. And we can provide lock on provisions here. We also we have essentially there's a spot where you would drill the hole for the lock on that is already there. So if somebody wanted to do that in the field as well, it can be done in the field.
Yeah. Yep. Okay. So, and that was another question. So we have to, if you drilled that out, you would be following our instructions on how to do that, and where to put that and all that good stuff. So that is a modification in the field that would not require a field evaluation by a field evaluation body because you're following manufacturer's instructions. So that would make sense. Okay. I'm liking it. Let's go back to this so I can move some things around over here and not drive everybody crazy. Okay, so these are just like bullet items I had in my head.
Yeah. So actually, I can tie. So you were talking about establishing an electrically safe work condition.
Yeah.
Some of the other things that we do around safety, we have a product. It's called a double door safety switch, um, where we separate the line power from the load power. Again, when you do shut off a switch at the line side, the conductors are still hot, right? They still have power at them. So the conductors and the lugs are technically still live on the line side of the switch. So we provide line shields in our heavy duty switches as a standard, not in general duty switches. That's again another difference.
Mm-hmm.
The line shields, prevent incidental contact of those line side lugs and line side conductors. But to take that one step further, the picture you see on the screen now is a double door. So we've actually now completely isolated and enclosed the line side power from the load side, and so you can actually operate on the load side. You could replace those fuses, for instance, that you see in this enclosure, while still having a fully enclosed line side power. So really just thinking through, safety. The other thing you see here that adds safety is the window at the top. That's another modification we do all day, every day. That allows you to actually see the contacts and see if they're making connection or not, right? So
Mm-hmm.
making sure that there's visible line of sight that the switch is off and no power should be flowing through the switch. Um, the yellow piece of plastic that you see inside of the top door, that's our arc shield, right? And so that is actually the yellow version is a safer version as well. So the red version is the standard. That's what you see inside of our normal safety, heavy duty safety switches. The yellow is it's part of our visible blade switch.
Okay.
And so what it's done is we've kind of done two things. We've opened up the holes to be able to see inside of them more clearly, see whether or not it's open or closed. And also the yellow provides a bit more I guess difference in the color right there, so that you can actually see better. You can make out the difference between the conductors and the plastic better. So it gives you that contrast, right, to be able to help. So that's kind of a couple simple modifications we do there. And those two doors are actually mechanically interlocked. Again, thinking through safety. So the bottom door can't be opened unless you put it in the off position as well, right?
Mm-hmm.
So there's several things like that. We also provide a switch called an OLI switch that does a similar thing. It takes the main disconnect of a panel and actually puts it into a separate switch that then you mount to that panel, so that you've
Right.
separated that line power, right? So there's lots of different things that we do to try to improve the safety overall, and those are just kind of some of the bullet points.
Yeah, the physical separation of that. So Robert asked about whether or not the yellow items are the barrier. Uh, those three holes, you can see the contacts, and that would tell me that that's not a barrier, because I could probably put my finger in there. But that top door is closed, so when I go into the off position, I can't open the top door. I can open the bottom door. I've established an electrically safe work condition when I replace those fuses, and I know that because that's the only disconnect. I can lock that and I can tag it out. But the nice thing is I am right there. Now, Seth, I know I've seen this also with presence of voltage indicators on them, to let you
Yes.
see that.
Yeah, that's a great. Yeah, I'm trying to think through some more of the safety mods. The voltage indication is a great device. We utilize Grace voltage indicators,
Mm.
which basically it's a little device that mounts on the door, um, and it detects whether or not there's voltage. So you can actually, another visual cue, right? Something right there that when you flip the switch, you can do either line or load side. A lot of times people do both. So that way, when you flip the switch into the off position, you can see line side voltage is present, the LED lights are lit, and load side voltage is not present, right? So that'll give you again another cue that this is safe. There's also a voltage test portal there. That's what the device is on the under the voltage indicator. The little blue circle is the voltage indicator. The voltage test portal is the device under that. Now you can see it better. And my buddy Jordan there showcasing the switch, where you can actually, physically test for the voltage inside of the voltage portal there. So yet again, another way to provide that visual cue, whether it's the window or the yellow visible blade or the voltage indicators, the grace voltage indicators there, all ways to improve upon the safety. We do the same thing with receptacles too. That's another way we add safety to our products, right? So we have interlocked
Oh yeah.
receptacle switches. So you were talking about your welder in your garage. I hope you have a weld receptacle switch upstream of it when you plug it in, just for extra safety.
I just have, it's a 120 volt, so I just plug it into my circuit, my 20 amp circuit upstairs. So it's just a regular 120 volt switch, or circuit. So, but I'm going to put in a 240 volt circuit so that I can weld on that. I can go when I pull that trigger, So, but
yeah, but those are interlocked too, right? So again, safety, thinking through, it has to be in the off position before you can either attach or plug it in or unplug it, right? So, and the same thing for cam lock receptacles, another type of a receptacle switch, right? Something where it's again interlocked, prevents you from being able to hook up or disconnect without actually going into the off position. So a lot of that, those are really a lot of the safety plays, right? Being able to physically see what's happening, making that more obvious whether or not there's voltage present, reducing that available fault current, incident current right there, right? That's big. Being able to plug up or hook up a portable generator or something like that in a safe way, transferring power between utility and generators, in a safe way. All these things are a lot of the things that we do here at to try to improve the safety of just a safety switch.
Yeah, and I was looking for. I know I had seen it down here, but I can't. It's a It was the inlets with the inlets, the interlocked inlets. What
Which are you, so which
like if I have a generator, there it is.
Okay, so it's a quick connect.
There it is,
Yep,
quick
there you go.
connect. I love this product because
Yeah.
I in fact there's a code change that occurred a few cycles ago, and I tried to get that I think it took me 2 cycles to get it in, so it's 6 years. Um, uh, I had an electrical inspector in Florida who sent me a bunch of pictures, photos of generators, portable generators plugged in with these connectors. And the important thing to remember is a lot of those connectors are not rated as a disconnect. So you can't pull those out while that generator's on. And his concern was, which I think is valid, his pictures were showing that inlet was like there's a gas station, a supermarket, and it's in a public area. The generator's out back around the building, so anybody could walk over. If a kid thought he was going to do a little practical joke and pull a connector apart, that could definitely result in an unintended rapid disassembly in the field, right? Possibly. So the requirement went into, and I should know which section, and I'll find it. I don't think it was 445, or maybe it was. It was portable generators. I think it was 702. That's where it was.
702.12.
Wow, you were awesome. 702.12. And I'll tell you what, I burned a lot of midnight fuel trying to get that through. And it wasn't easy until I figured out where it goes. So Power inlets rated 100 amps or greater for portable generators. Equipment containing power inlets for the connection of generator source shall be listed for the intended use. Systems with power inlets shall be equipped with an interlocked disconnecting means. And then it says the only exception is if the inlet is rated as a disconnecting means, but none of those are. Okay, and if there is one out there, it's definitely not the norm. So this one in the code and this disconnect, what's nice is when you close this door and close that door and turn it on, you can't open either of those doors and you can't pull those out. That's so nice.
Yep. Yeah. No, it's a definitely a great safety play. You know, and to add even to the safety level of that, I mean, if you just think about switching between utility power and generator power, right?
Mhm.
This is an incredibly safe way to do that. Safe, you know, you cannot have them both on at the same time if you're using a quick connect double throw safety switch. So it's a really great product. This one is one of our fastest growing products, actually.
Is that right? And this is the double throw. That's this one on the right.
Correct. Yes.
Yep. Explain double throw.
Yeah. So you've got one load and two lines. So it's actually got three positions on the handle. So you got your on, off, and on, typically speaking. And what the most common application would be, like, we're talking portable generators. So imagine a convenience store or gas station. Natural disaster comes through, a hurricane comes through. I grew up in Florida. Hurricane comes through, power goes out in the facility, which is typically your first on state, right? Well, in order to get your gas station back up and running so you can provide fuel to people trying to get around and service the town that's been hit by the hurricane, they bring in a portable generator. They want to then hook up the portable generator. In a situation like this, what you do is you actually put the switch into the off position, and that'll allow you to open up the door where the cam locks are in the bottom compartment there. And you can actually then plug in your cam locks. Obviously, you have cam locks or posi locks if you want to add another layer of safety. So cam locks, right?
What's a posi lock? I don't know, David. Do you know what a posi lock is? I don't know. What's a
I do
posi?
not. No, sir.
What's a posi lock?
Yeah, so it's same concept as a cam lock, except for it forces you to install the conductors in a very specific sequence. It sequentially forces you to install the conductors
Oh,
and
interesting.
remove them.
Oh, cool. So if I wanted to make sure my ground was the first and last, I could. Okay, perfect. I like that.
Yeah. So typically speaking, it's just cam locks, right? Posi locks is kind of an upgraded version of it. But yeah, that they would be able to come up, they'd hook up their portable generator, and then they could then go to the bottom part, right? The second on portion of the switch, where now your generator is supplying the power to the load. So you can never have that utility power on at the same time as the generator power feeding the facility, which is obviously bad. And then same thing to go back, right? You would switch it into the off position. You could then remove your cam locks and go up into the original on position, going back to utility power when it's come back online.
I like it. I like it. And and what I like about all of the stuff that you guys come out with and the switches. I mean, just when you thought a switch is just a switch, I mean, I always thought
It's a fancy on-off switch at the end of the day, but we can do it in many ways.
it's absolutely insane. I mean, this is like buying tennis shoes. I remember when I was a kid, you bought a pair of tennis shoes. It was tennis shoes. Now it's like you go to the store and it's like, are you going to run in these? I'm like, well, yeah. Well, actually, I'm more like jogging. Oh, that's over here. That's I mean, I've never seen so many freaking shoes. It's amazing. What kind of shoe you wear, David?
I try not to. I'm from West Virginia.
I'm West Virginia. West by God, Virginia. It's all good. It's all good. All right. So I love that one. And then you have the elevator control switch, which
Yep.
adds some even more features. That tells you it adds some accessories for knowing that the elevator control system needs. I'm just looking through. So, the I could do too is I wonder if you have the arc reduction in here. Flange mounted shunt trip. There's the shunt trip switch.
So if you just Google arc reduction relay E10, you'll find it real quick.
Yeah, I mean, I know I've got this catalog here, which is really good. But I was just okay. Wait.
Yeah, I think that's the one. If you go to the top, it has a picture of it. So you
Yeah. So
can,
this is this is when you go down to a 400 amp switch, 400 through 5,000 amps. So that was the earlier discussion that we had. We weren't sure on what exactly where the offerings were, but the custom shop, man. Special orders don't upset us.
not at all.
This is cool stuff. So, all right. So, okay. So, and Ryan made a statement about 406.13. I'm just going to look at 406.13 because 406 is receptacles and connectors and attachment plugs. 406.13 says single pole separable connector types. Single pole separable connectors shall be listed and labeled and should comply with 13A through D. Locking and latching. Locking or latching type and marked with the manufacturer's names. So you lock that. I mean, you can't pull it out, so you would technically. And then identification, interchangeability, disconnecting. The use of single pole separable connectors shall be performed by a qualified person. Connection and disconnections. I'd have to really read through this. So Ryan might point out an interesting. This might be another area that you can explore too. To say, hey, we can help you meet 406.13 in the National Electrical Code around separable connectors, but I'm not sure about that. I got to really read it. All right, so let's see. What else did I want to cover? We talked about, I'm just checking off. We talked about the single throw versus double throw. Did we talk about, yeah, we did single throw versus double throw, right? Yeah.
Mm-hmm.
404.8, 6'7" above the floor, that handle. So the length of, that's why I was going through this. That length of the handle. I mean, there's no, I mean, we put that length on because it helps you open and close that switch. There's nothing in the standard that says it has to be so many inches long.
No, I do not believe there's anything that says how big the handle has to be, but I do know that the handle location is important from the floor, right? So being able to reach the handle, I believe it's 6'6", if I'm not mistaken.
Yeah, 6'7" is
6'7". I was an inch off.
You were an inch off. That's okay.
I don't have that problem. I'm 5'10", so I think I don't know what it's like to be up that high.
Yeah, me neither. Join the club. 404. I think it's 404.8. I thought. Let me just make sure. Yeah, 404.8. Is it? There it is. Location. All switches and circuit breakers used as switches shall be located so that they may be operated from a readily accessible place. They shall be installed so that the center of the grip of the operating handle of the switch or circuit breaker, when its highest position, is not more than 6'7" above the floor or working platform. So,
yeah, so that's taken into consideration in design for sure, right? So when we make our 1200 amp switches and things that get really large,
that's right.
We do have to consider where the handle ends up when it's in the off position.
Yeah, because those big boys, those they're really tall. They're probably like close to the ground or sitting on the ground whenever you. So that handle, yeah, that's a good point.
Yeah, we're working on one right now that's like 87 inches tall. So it's a big switch.
Wow, that I got a 1200 amp switch delivered up to the Experience Center, and I forget who it was. I was talking on the phone. They called me up and they said, "Hey Tom, where do you want us to ship this to?" And I was thinking to myself, I'm not sure about if I just ship it up to the experience center, but I'm thinking in my mind, I'm thinking, well, maybe I'll just have you ship it to my house and I'll throw it in my truck in the back of my SUV and I'll drive it up. Well, and then
Pop it in.
I decided against that. And I went up and Dan Carnivale goes, hey, he says, there's switches in. He says, let's go take a look at it. I'm like, holy God, this is a big switch. I would have never
yeah.
fit that in my truck.
That was
Huge.
actually one of the first things that shocked me when I started in this role was how big they actually get. I did not realize how physically large a switch can be.
There.
Tom, that just means you need to get a bigger truck. That's all that means.
Yeah. Absolutely. I need an F350.
There you go.
I could have put it in my F250, my F150. I could have, but at the time I hadn't fixed my frame, so it was out of commish.
There you go.
All right, and then I had a note here: bolted pressure versus knife switch versus snap switch. We already talked about the snap switch. The knife switch is what we were looking at, right? That's that knife blade that's going to come down on a contact. But then the bolted pressure switches, those are larger. I can't remember what the smallest bolted pressure switch is, but they're talking about the pressure of the contact and sort of doing this as opposed to this, right?
Right.
So, and that's in 404. There's a couple references to the bolted pressure versus knife switches, etc.
They start at 800 amps.
800 amps. Okay, so your bolted pressure starts at 800 amps, and your general duty and your heavy duty go down to 30. I think we said, which you could
Correct.
fuse even lower than 30. So I could have a 20
Yep.
amp with a disconnect switch, and the size changes proportionately.
Yeah, it's pretty drastic. Those are very large switches.
Yeah. Yep.
Tom, very quickly, I'm just going to sneak in here very quickly. Unfortunately,
Yeah.
I have a hard stop here coming up very soon,
Me too.
and my hardware is about to run out of battery. But I do want to say thank you very much, everybody, for coming on. Seth, I very much appreciate it. That by no means, guys, please continue the conversation after I head out of here. I was going to say next Tuesday, there's going to be a state code adoption meeting for West Virginia going to be at the same time here. So I'm not going to be able to make it then, but I believe we're going to be kicking off Electrical Safety Month for the first Tuesday in May, and I'm really looking forward to all the shows that we have in May. And so, Tom,
Safety Month, yes,
very much appreciate it.
not a problem. And David, the other challenge in West Virginia, if I'm not mistaken, is the whole rules and regulations on the electrical contractors who can come in from out of state, what training is required. That's a whole. Is that the meeting that you're going to, or is it an adoption meeting?
It's an adoption meeting, but I believe there's going to be discussion in the legislature while I'm there about some of the licensing requirements for skilled labor, including electricians. And so that is another thing that's going to be directly on our radar.
That is so cool. And I went through all of the stuff that I wanted to get through, Seth. I don't know if there's anything that you wanted to get through, or David, any last items, because I'm pretty much closed up shop as well.
Yeah, that's it for me, Seth. Thank you very much for coming on. And I know that, sometimes these shows on Tuesdays can be so fun. You forget how much time is going by, but I very much appreciate it. And anytime you want to come back on, if you have any other products that are coming out, and I know you mentioned earlier that there's going to be something in R&D that you guys are cooking up. And so if you ever want to come on there and pretty much feature that and tell us about the launch and everything like that, I think that'd be fantastic.
Absolutely. Awesome. Absolutely.
Yeah. No, I appreciate that. I definitely look forward to getting on here again. Thanks for having me. I enjoyed the conversation quite a bit.
Perfect. Excellent. I don't know if I tried to keep up with all the chats. I didn't have anything. We went through a lot of stuff that's in 404, but then we did show that it's not just 404 with switches. You got to think about 230. You got to think about 240. You got to think about all these different areas in the National Electrical Code where you would be using switches, voltage, current, short circuit current ratings, enclosure ratings, ampacity and lugged, and what you can do in your from a termination perspective. We covered a lot of material in the last almost 2 hours here, so I really appreciate your time, Seth.
Yeah, no, thank you guys. I appreciate it as well.
Perfect.
All right, well, everybody, I'm done. I think I'm done. Thank you, Seth, for joining in.
My pleasure. Thanks, guys. Have a
Thank
good
you.
night.
You too.
Take care.
All right. Take care, guys. I'm going to just go on me and I'm going to close up. Okay, everybody?
Perfect.
Cool. All right. So that was a good session on safety switches with Seth and David Smith. Does this piece of equipment meet the absence of voltage requirements 120.5 live test processing? Just to answer that question, Robert, before I sign off, 70E is looking at the absence of voltage testing. So Tamaki was on too. Thank you for joining us. So they're recognizing more and more those absence of voltage. I know that was, I believe, reviewed and is probably going to be in the next version. It might be in the 2021. I'd have to take a look, but they're recognizing that product more and more in 70E. I know in 2023 code, they were trying to get that required in some applications. So stay tuned on that. Thank you, George. Thank you, Tamaki. Thanks, Robert. Ryan Jackson. Awesome. Thank you for joining us on this safety disconnect switch. And I'm going to be signing off. So thanks. Take care. Stay safe. God bless. All that jazz. And please stay healthy. All right, everybody. I am going to find the button to hit end. And Daryl Hill, happy birthday, buddy. I hope you enjoyed your birthday. That new car you had, I saw that. Psych. All right, take care, everybody. Signing off. Good night. See you Thursday. See you Thursday.